Okay, tonight's video is a continuation of what we've been doing area by slicing. Remember, in the end, everything is going to be the integral of upper minus lower, SEPLO. And the way we've been thinking about the problem is the following. If I have a curve, f of x, or I can call it y, what I'm thinking of doing is I'm thinking of slicing along the x-axis. I'm taking all my big piece of x, and I'm turning it into little pieces of x all the same width. I'm making them all dx. Now I have to erase all those so we can undo them really quick. Too many of them there. And we're thinking of taking we're thinking of turning this all into strips by slicing it. We're making the width of all of them the same, dx, and the height is going to be y. So the area of one strip is y times dx. And then we integrate it to add them all together. And what we would have, like let's say the graph of this equation was y equals x squared, we would then take this equation and fill in the x squared to get the integral of x squared dx. So I have a y in here, and then I have dx's, but I end up turning the whole equation into x values because this height here is equal to x squared. I know I might have made the problem a little more complicated than just saying upper minus lower, but that's technically what's going on there. I'm slicing things up. And it's always nice when we can slice things along the x-axis because it all makes sense to us. Sometimes, though, we cannot slice things along the x-axis, and I will show you why. Here's two curves, and let's say I was doing upper minus lower. And I'm going to draw a rectangle for upper minus lower. Well, for that region, it's easy. The orange is above the green, but what happens if I come over here? Now it's involving the orange and the orange. And when this happens is when you have multiple versions of y in there, like so. And there's two ways to think about this problem. I'm going to show you the main method for doing it, and then I'm going to show you the shortcut, which is instead of slicing along the x-axis, we're going to slice along the y-axis, meaning we're going to slice like taking a knife. That's my knife, and we're going to slice off pieces of it. Awesome sound effect. By chopping the y-axis up evenly. Now I'm going to erase all this here. And I always visualize the problem by just drawing one slice in. I'm going in this direction right here. That means my thickness right here is going to be dy. It's going to be dy. So I'm integrating whatever the height, the length of it is times dy. And the length is always going to be upper minus lower. It's the x from the upper curve, however far this is, because this is the x in this direction, minus the x over here, which is a negative number, which is why they're going to combine to give us a positive number. I'm putting those two things together. But my problem is it's going to be x of the one minus the x of the other being upper and lower. So the first thing I'm going to think about is, well, who's the upper and who's the lower, and how do I have to have x by itself in the equation. So in terms of thinking of the graph, I actually think of turning the graph sideways. I'll take my whole graph, and I can't do it right now, and I'll turn it so it's facing up. So I have the orange curve is the upper curve because it heads farther in the positive x direction than the green curve does. And I know the description isn't perfect. You have to try it a couple times to sort of get it. So I know that the upper curve is going to be this one, and the lower curve is going to be this one. So it's going to be the integral of, in parentheses, 3 plus 2y minus y squared minus whatever x is in this equation. Now you'll notice x is not by itself, so I'll get x by itself. X equals negative 1 minus y. Negative 1 minus y to the, close it, dy. Now my equation is totally in terms of dy, of y's and dy's, and I could find the starting point, which is here, and the ending point, which is here, and I could integrate the problem just like that. The other thing you can do, which I find a lot easier sometimes, is it's hard sometimes to think about doing these things in terms of the y direction. So what I will often do is literally just rewrite the equations by switching all the x's and y's. I'll switch them all, and then I get a better picture. Let me show you what I mean. Okay, so I just rewrote, I took the original problem I had over here, and I just did something to it. Now, I'm going to be honest, I intentionally made this sound a little complicated as I was working on it, because think about it is, take a look, what's the difference between the two equations that are circled right there and the equations right here? Correct. The answer is I just switched the x's and y's. Take a look, the x's and y's are just switched. So, just so you know, your demonstration of you having completed watching the video is you are going to text or remind to me that Mr. Brigham, Mr. B switched. That says switched. X and Y. Once I see that in my text, I will know that you have viewed this video. But now that I've switched them, if I graph them, if I were to graph them, the graph of them looks like this. Oop, didn't want that color. And from this picture, I very clearly know who's the upper curve. Well, first of all, I have one problem, is that I should have everything with y by itself. So this one's all set. So I'm going to subtract x from this side. I know, I was there a second ago. So this becomes y equals -1 minus x. It's clear that this is the upper curve. Because if I draw a little rectangle, it's obvious to see that's on top. It's clear this is the lower curve. And the question of where to start and where to finish are where these things intersect. So I could either graph it in my calculator and find those intersections, graphically, or I can set the two equations equal to each other. Let's try that. So here's the equation set equal to each other. When it's a quadratic, I'm going to move everything over to one side. So I'm going to add x. Then I'm going to add 1. And I've got 4 plus 3x minus x squared equals 0. I'm going to reorder these. So I've got negative x squared plus 3x plus 4 equals 0. And now I'm going to factor it. Now, the one trick they like to do is this right here. Right now, my equation has a negative x squared on it. We don't factor when we have that negative x squared. I'm going to multiply the entire equation by -1. You can think of it as moving everything to the other side. And I get x squared minus 3x minus 4 equals 0. Now I should be able to factor away. Hoping I can. I've got an x. I've got an x. I've got a minus and a plus. I've got a minus 4 and a plus 3. Oh, who said plus 3? Nice try. Plus 1. I set them both equal to 0. X plus 1 equals 0. X equals -1. So now I know. I'm going to come back to the original problem for a second. I'm integrating from, give myself a little space here. I'm integrating from -1 to 4 of the upper curve minus the lower curve, close parentheses, dx. That will give me the correct answer back. But if you ever have to rewrite it out, I'm going to move back to this problem right here, and they originally started out with y's, all you have to do is take the equation you have and change all the x's back into y's. So a lot of stuff going on in this video. Let me just quickly review what happened here. We originally sliced by slicing along the x-axis. Sometimes we have to slice along the y-axis, but that makes sometimes understanding the problem confusing. You can still probably figure it out, but it makes the problem confusing. The way I like to work these problems is I will convert all the x's to y's and all the y's to x's, and just work with a visual exactly as I had before. So now that I have that equation, this will give me the right answer. If I put that in there, I'm going to get, I believe, 20.83. If I got negative 20, if I had negative 20.83, it means I probably went in the wrong direction, but it's still always upper minus lower, and you need to just get your variable, equation in terms of y. So we will work on this tomorrow. Don't worry if it doesn't make 100% sense. As long as you can follow along, we'll be ready to go. Take care.